In this video, we're going to look at how we can construct half equations. So you may have come across half equations previously in the course, but it's really key for electrochemistry in particular that you understand how the different half equations can be formed. So let's have a look. There's 4 simple rules as to how to construct them. First of all, you write the formulae of the oxidized and the reduced species down. You then insert the required number of electrons. You then insert any water molecules that are required to balance any oxygens, and then if there's any hydrogens left to balance, you insert H+ ions. So let's have a look at an example. So we're going to go from zinc 2+ to zinc. So this is relatively straightforward. We write the formulae of the oxidized and the reduced species, and as you can see, I'm going from zinc in an oxidation state of +2 to zinc in an oxidation state of 0. So I need to add 2 electrons. And now that is correct because I don't require to do 3 or 4 because I haven't got any H's or O's in that equation. So slightly more difficult one now, we're going to construct the equation for BrO3- going to Br-. So again, write the formulae down. Now we're going to insert the required number of electrons. So bromine on the left hand side is an oxidation state +5 and it becomes -1 on the right hand side. So that means bromine must have gained 6 electrons. Right, so you can see on the left hand side I've got 3 oxygens in BrO3-, so I need to now add 3 H2Os on the right hand side to balance those. And now that means I have 6 hydrogens on the right hand side, so I'm going to add 6H+. And that's complete. Example 3, I'm going to go from Cl2 to ClO- in alkaline conditions now. So again, go through the rules, write the formulae down. So chlorine has gone from 0 to +1. But if you notice, chlorine Cl2, I've got 2 of those. So each of those change, so it's a change of +1, but because it's a change of +1 per chlorine, there's an overall change of +2. So therefore, it's gone from Cl2 to 2Clo- plus 2 electrons. Now I need to insert the water molecules. So you can see I had 2 Clo- on the right, so I need to put in 2 H2O on the left. And finally, I'm going to balance those 4 hydrogens on the left hand side with 4 H+. If you have a look in the example, it tells you that this reaction is done in alkaline conditions. So those 4H+ that we have generated are going to react with the OH- ions that are present to produce water. So we now have a product of 4H2O. However, one of our reactants is also H2O, so we can cancel those out to give us our final answer as that.